Hey, so this research video is called Higgs Boson Axitronics Dark Energy Neutrinos Axial Chameleon Force W Bosons 5G while SETI. This is a graph of neutrinos, axitronics, fifth forces, and dark energy. This is the fifth force to explain the handiness of the weak force by Barry Adams. This is based on some of his research that came up in the data. He blogged this August 16th, 2012 at 4:36 p.m., so it's quite recent. So data quotes, let us introduce a force that has an opposite charge on left and right-handed particles. Due to quantum anomalies, electrons cannot feel such a force. But neutrinos, on the other hand, seem to need such a force. The equations of motion of particles allow for forces that act either equally between opposite spins, vector forces, and ones that act oppositely between opposite spins, axial forces. So we may introduce an axial force between neutrinos. Noticing that beta decay produces both an electron and an anti-neutrino, we may see that a W particle would hold both charges of both the vector electric force and neutrino axial forces. The W particle's VA vector axial nature, first noted by Enrico Fermi, is then derived from the combination of forces on electron and neutrinos. That the weak force has a VA nature was completely unexpected and was discovered after experimenters noticed that electrons emitted by decaying cobalt-60 held in a magnetic field only spun in the left-handed direction. The weak force was from then on described as left-handed VA force, but no clear mechanism arrived at for explaining why the weak force left-handed. In fact, under the symmetry of special relativity, left-handedness doesn't remain left-handed. You may overtake a particle spinning in a left-handed manner compared with its direction of motion. Looking backwards, you would see a right-handed spinning particle. Thus, relativity needs a right-handed force as well as a left-handed force, and right-handed as well as left-handed neutrinos. In addition, it has been proved by L.M. Slad that an axial force is needed in addition to a left and right-handed weak force in order to give a definite handiness to the fields that survives relativistic transformations. Having an axial force allows a neutrino to reverse its direction without reversing its handiness. It merely emitted a spin 1 axiphoton after the reversal. It is the axiphoton that carries the fifth force. The symmetry of the axial force allows left and right-handed neutrino and left and right-handed W particles, the carriers of the weak force, to have different masses. This is possible because an axial force is created by gauge invariance, Atoms 1, Section 2. Whenever a particle has its mass described by as a Majorana mass with different masses for left and right-handed particles. The asymmetry noticed at low energy that neutrinos are light and left-handed and that the weak force has a mass and is left-handed. Then required another symmetry, that of the axial force. We thus have three reasons for believing in an axial force. Barry writes that, number one, that gauge invariance is possible for neutrinos with Majorana mass implies an axial force. Number two, that the weak force handiness is compatible with relativity implies an axial force. 3. That is, the weak force is VA, may be retrodited from an axial force between neutrinos. I have been investigating the axial force for some 5 years now, so he's been doing this for 5 years, and have blogged about it frequently at my previous blog site and written several papers for it. I managed to use this is Barry talking, not me, okay? I managed to use the axial force to defend casualty, if neutrinos happen to travel faster than light. This I now regret, as the opera experiment that saw faster than light neutrinos turned out to be incorrect. The axial force works whatever the speed of neutrinos are, both normal masses or tachyonic masses is fine to the axial force. I have found that the axial force could be quite strong, maybe as strong as the 60th of the strength of the electromagnetic force, and still not be noticed. The reason is that neutrinos are so very light that the slightest forces on them causes them to move very quickly. As large measurement distances bigger than 5 nanometers in air and much less in solids, the axial force is completely screened by the motions of background neutrinos. This makes the axial force a chameleon force, hidden from normal experiments, and explains why it has not been detected by other experiments. For my next article, I will write of an experiment that might detect an axial force and hope I can get experimentalists to try performing it. So again, here's another scientist that's working out formulas and ideas for you to try, and he needs you to try it to see if this, to prove that the axial force exists. So I would take a look at his blog as well. It's www.science20.com. Okay, and posting for this research purpose, I only use this as a research purpose only, just so Barry knows. Keywords: axial force, chameleon force. So I'm going to Google chameleon force because I don't know what it means. So chameleon force is www.nat.vu.nl condmat Ian research chameleon.phpshare. Okay, long link there. Chameleon force. Chameleon fields are one of the candidates to explain the origin of the acceleration of our universe and the nature of dark energy. So again, we're brought back to dark energy, dark matter. Okay, so there's the Google link there. So August 17th was when I was working on this. Today is September the 8th. My thoughts: the Higgs boson has opposite forces on either side of it from the test results. The keywords were gauge invariance, Majorana mass, relativity, tachyonic masses, electromagnetic force, asymmetry, low energy. Key for Higgs boson particles is asymmetry plus low energy. So when we're looking at the Higgs boson particle with mass, we want to look at asymmetry and low energy. Those are two keywords we want to look at with that. So we're going to explore more keywords in the next blog post or in the next video, okay? Thank you for watching.